We have our common assessment number 6 tomorrow over expressions. So let's look at this first question. It says match each set of equivalent expressions with the property that makes it true. So you can find this on page 36 in your notebook. That's where we have all of the properties listed out. So I'm going to start with commutative because that was the first one that we listed in our little chant. We said commutative, change order, commutative, change order. So we're looking for one where the numbers are switching order. So if you look at this first one up here, it's 3 plus 2 plus p, but then it says p plus 3 plus 2. They took the numbers, they're still being all added together, but they've changed the order. So this would be an example of the commutative property. The second one in our chant was associative. We said associative, parentheses change, associative, parentheses change. So I have two here that have parentheses, but in this first one, the parentheses didn't change. They actually went away completely. Here we have all multiplication, but the parentheses went from being around the 3 and the 5 to being around the 3 and the 2. So because those parentheses changed places, that would be an example of the associative property. In our chant, we said identity stays the same, and we make a 0 and a 1 when we do that because you can add 0 or multiply by 1 and the number stays the same. So right here we see we're adding 0 and the -3 kept its identity. It stayed the same. For inverse, we said opposite or reciprocal. So I don't see anything about opposites here, but I do see a reciprocal because 4 over 1 and 1 over 4, those are reciprocals. So the inverse property says that if you multiply by a reciprocal, you get 1. You always get 1. So that would be inverse. And then in the chant, we say distributive hippity-hoppity, distributive hippity-hoppity. We also make the symbol of the parentheses. So remember, in distributive, you start with parentheses, but you do your hippity-hoppity distributive property where you're distributing that multiplication. So the hippity says 7 times W is 7W. The hoppity says 7 times 12 is 84. So this one right here is an example of the distributive property. Question number 2, evaluate the expressions. So we have two. They are both GEMDAS problems. So I'm going to write my GEMDAS out to the side. This is order of operations. This is in your notes on page 34. On this first one, we don't have any grouping symbols. We do have exponents, though. I would always recommend that if you have exponents that you write it out in expanded form. So 6 to the second power means 6 multiplied 2 times. 6 times 6 is 36. I'm going to keep everything else the same. So I'm done with exponents. Now we multiply and divide from left to right. So I'm going to do this one first because it's on the left. 36 divided by 3 is 12. We're still on the multiplication and division step, so I'm going to do 5 times 2, which is 10. Last but not least, we're on the adding and subtracting step, and we add and subtract from left to right. So I'm going to do 100 minus 12, because that's on the left. 100 minus 12 is 88. And then the last one is 88 plus 10, which is 98. So you should get 98 for the first one. On this next one, we also need to use our GEMDAS rules. We don't have any grouping symbols, but we do have exponents. Now, again, I would really recommend you write this out in expanded form. -3 times -3 times -3, because we've got to use Dorito Man here. So the first -3 times -3, that's going to give us a +9. But then we have to do +9 times -3, and that's going to give us -27. And then we don't have any multiplication or division, but we can do this adding. And because this is same sign, we find the sum. So 27 plus 7 would be 34, and we keep the same sign. So that one would be -34. Okay, question number 3 is about equivalent expressions. And so you can find notes on this on page 38. A good way to solve this problem is to substitute 2 everywhere where you see M. So I'm going to do that in the problem, but I'm also going to do that in every answer choice. If this were your test, you'd just copy all these down, but instead of M, you would write 2. So up here, 2 times 32 is going to give me 64. So that means I'm looking for one of these to also equal 64. So here I do 2 times 30, which is 60, and 60 plus 2 is 62. That's close, but close isn't good enough, so that's not going to be our answer. On this one, I do 2 times 30, which is also 60, but this time I'm multiplying by 2, so that's going to give me 120. That's not even close. Here I do the 2 times 30, that gives me 60. The 2 times 2 gives me 4, and the 60 plus the 4 does give me 64. So that looks good, but I'll come back to it because we need to double check the last one. On the last one, 2 times 3 is 6, and 6 plus 2 is 8, not even close. So C ended up being our answer for that one. Question number 4 is about prime factorization. You can find that on page 33. Make sure you remember what a prime number is, because on these you can only use prime numbers. And remember that the first 5 prime numbers are 2, 3, 5, 7, and 11. Those are going to be the ones you use the most in prime factorization. Now, because 180 ends in 0, I know it's even. That means it's divisible by 2. Half of 180 is going to be 90. I can divide 90 by 2, and that's going to give me 45. I could have also divided each of those by 5. It's just up to you what it's divisible by and what is easy for you. And you could also work it out to the side if you're not sure what it equals. 45, I'm going to go ahead and divide by 5. That's going to give me 9. And I know I can divide 9 by 3, which gives me 3. I can divide 3 by 3, which gives me 1. Now I'm going to go least to greatest. So 2 times 2 times 3 times 3 times 5. And then put it in exponential form. So 2 times 2 is the same thing as 2 to the second power. 3 times 3 is the same thing as 3 to the second power. And then there's just the 1 5. So this is my answer, but I can always double check my answer by multiplying it out. 2 to the second power is 4. 3 to the second power is 9. So 4 times 9 is 36. And just some quick math over here, 36 times 5 is 180. So I know that that is right. If this were a multiple choice question, just be careful. There might be an answer choice that if you multiply it, it equals 180, but maybe it had a 9 in it. Well, 9's not prime. Or maybe it had a 4 in it. 4 is not prime. So make sure that your answer that you're choosing only has prime numbers. And remember that a prime number just means it's only divisible by 1 and itself. It can't have any other factors. Okay, next question, number 5. It says, what is the value of the expression below? This is another GEMDAS problem. So this can be found on page 34. Again, we want to write out our GEMDAS steps. Okay, so we do have grouping symbols this time. 12 minus 4 is 8. Everything else is going to come down exactly the same as it was. We do have exponents. So again, I would recommend writing out the expanded form so that you can work it out. 2 times 2 is 4. 4 times 2 is 8. And 8 times 2 is 16. So this is 16. Everything else is staying the same. Okay, the next one says multiply and divide from left to right. So this one's on the left. 16 divided by 8 is 2. I've still got some multiplication. 8 times 4 is 32. And then last but not least, we add and subtract from left to right. So 10 minus 2 is 8. And 8 plus 32 is 40. Okay, so we just talked about prime factorization on the last problem. Again, this is on page 33. This one says, which one is not an example of prime factorization and why? And so they didn't tell us to find the prime factorization. So we're not even trying to say such and such is the prime factorization of some number. There's literally one of these that cannot be prime factorization, and it's because of that word prime. Remember that prime factorization has to have all prime numbers. 3 is prime, 5 is prime, 11 is prime, 2 is prime, 7 is prime, 13 is the one that comes right after 11. So 13 is prime. We said 3 was prime. But 9 is not a prime number. It is divisible by 1 and it is divisible by 9, so it fits those two. But it's also divisible by 3. 3 times 3 is 9. So if it has any other factors or numbers you can multiply together to get that number, then it's not prime. So I'm going to say D is not an example of prime factorization because 9 is not prime. Okay. Number 7, circle all the expressions. I believe this is found on page 35. So those notes on page 35 are expressions versus equations. It's easier to pick out an equation. Equations have equal sign. So we see an equal sign here. We see an equal sign here. So we know those are equations. Also remember that is means equal. So when it says is 16, that means it equals 16. And when this one says is 2, that means equals 2. So all of those are equations. We were looking for expressions. Expressions are the ones without the equal sign. So this one is an expression. It doesn't tell us the answer. This one is, and this one is. None of those had an equal sign or told us is the answer, which would mean equals the answer. And last but not least, we have this model, and this is about evaluating expressions. And so evaluating expressions is on page 38. It's on the left side of page 38. It says, which value of n makes this equation true? This is that one where we just have to test them all out. So first, I'm going to try if n equals 1. So that means all of these n's would be 1. So that's 1, 2, 3, 4, 5, 6, 7. So 7 on this side. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 on this side. So that doesn't work. Those aren't equal. It says which one makes it true, and it is not true that 7 equals 9. Okay, so now we're going to try if n equals 2. So all of these would be 2. So that's 2, 4, 6, 8, 9, 10, 11 on this side. 2, 4, 5, 6, 7, 8, 9, 10, 11 on this side. Okay, so that seems like it is right, but let's double check the other ones. If n is 3, so that's all of these are 3. So 3, 6, 9, 12, and then 13, 14, 15. 15 on this side. 3, 6, 7, 8, 9, 10, 11, 12, 13 on this side. 15 does not equal 13, so we know that's not the answer. And then the last answer choice is if n equals 4. So if all of these are 4, 4, 8, 12, 16, and then 17, 18, 19 on this side. And then 4, 8, 9, 10, 11, 12, 13, 14, 15 on this side. 19 does not equal 15, so that's not true. So that tells us B was our answer because it's the only one where we got the same thing on both sides. We have this equal sign in the middle, so whichever answer we pick, it should give us the same thing on both sides. Okay, I hope that helped, and I hope you do great on tomorrow's test.